Okay, so this is the first review video for AP Calculus. Each video is going to review one unit, but remember that these are review videos, not an instructional video, so I wouldn't try to learn a new topic with them because of how fast the video will move. And there will also be a problem solving video where I solve problems of varying difficulties for each unit. And this can be used for both AB and BC Calculus. I'll make sure to mention when certain topics are for BC only, so people taking AB won't waste their time. So without further ado, let's get on to the first unit. This unit covers limits, which will be very important going forward. Let's start by looking at this graph. To find a limit at a point, look at what value the graph approaches from both sides. If it approaches the same number from both sides, the limit exists at that point. On this graph, at x equals 2, for example, the limit would be 3, even though there's a hole at x equals 2. We would say the limit as x approaches 2 of f of x would be 3. So limit still exists at removable discontinuities. However, at jump or infinite discontinuities, it's clear in the pictures that the function does not approach the same value from both sides, so the limit does not exist. If we have two functions f of x and g of x, we can find the limit of combinations of the two functions, such as f of x plus g of x, by finding the limit of the combination from the left and from the right. For example, in these graphs, if we want to find the limit of f of x plus g of x as x approaches -1, we can find the limit from the left and the limit from the right. This would be 0 plus 1, which is 1. And this would be 1 plus 0, which is 1. So since these are both the same, we would say this limit in general would be 1. For computing limits, start by plugging in the number. This is the easiest method, although often it won't work because the denominator will be 0. Like in this limit, just plug in 1 to get the answer of 3. If that doesn't work, as in this example, you might have to manipulate the equation in some way to cancel something, such as by factoring or by multiplying by the conjugate. If that does not work either, your answer will either be positive infinity, negative infinity, or DNE, does not exist. The easiest way to solve it is to take the limit as x approaches the number you're interested in from the left and from the right. And if these approach the same thing, then that's going to be the limit of your function. For example, if this approaches infinity and this approaches infinity, then you can say, in general, the limit as x approaches a of f of x equals infinity. Sometimes we want to take the limit as x approaches infinity. This is the end behavior. The function can approach positive infinity, negative infinity, or a number. If it approaches some number L, like in this image, we say that the function has a horizontal asymptote at L. So there are three important limits that you should know by heart. First, the limit as n approaches infinity of 1 plus 1 over n to the n. This limit equals e. You might see variations of this limit where the signs are changed, but if you see something in this general form, you should think, oh, this has something to do with e. Next, the limit as x approaches 0 of sine of x over x. This limit equals 1. Finally, the limit as x approaches 0 of 1 minus cosine of x over x. This limit equals 0. I forgot to write down this limit equals 1. And so if we were given this limit, for example, we would rewrite that tan is equal to sine over cosine. So we would rewrite this limit as sine of x over x times 1 over cosine of x. And we know that this part just goes to 1. So we have the limit as x approaches 0 of 1 over cosine of x, and then we can simply plug in 0 to get our final answer of 1. If we were given limits involving polynomials, the first step you want to do is look at the powers. In this example, the power on top is higher than the power on the bottom. So when we're taking a limit that's going to infinity of a number where the power on top is greater than the power on bottom, your answer is either going to be positive or negative infinity. It depends on the case. And then in this example, where the power is greater on the bottom than on the top, the answer is going to be 0. So here it's greater on the bottom than the top, so the limit is 0. And then here, where you have equal powers, you're going to look at your coefficients. So the coefficient for this guy is 1. The coefficient for this guy is square root of 5. So this limit is going to approach 1 over the square root of 5. So we define a function as continuous at C if the limit of f of x as x approaches C exists, if f of C exists, and these two parts are equal. If these are both equal, and these both exist, then we define the function as continuous. We can use this definition in the intermediate value theorem, which says that if f of x is continuous on the closed interval a to b, and k is some number between f of a and f of b, then there's at least one number x in the interval a to b, such that f of x equals k. So what this means is that if we have a continuous function between a and b, then at any point we can say that if we can choose some point here between f of a and f of b, we can call this point k, and we can say, alright, any point k, there's going to be at least one corresponding x value that has the y value of k. In this point we have 1, but if our k value was instead somewhere down here, then we'd have 1, 2, even 3 x values that correspond with that 1 k value. Finally, we're going to look at the squeeze theorem. The squeeze theorem helps us find the limits of unknown functions by comparing it to two other functions. So what we can say is that if we want to find the limit of g of x at this point a, and f of x is always less than g of x, which is less than h of x, and we know the limit of f of x and g of x, so at this point we know the limit of f of x as x approaches a, and we know the limit of h of x as x approaches a, and if these two limits are equal, then we know that the limit as x approaches a of g of x is going to be equal to that same thing. And in this graph, it is clear that h of x is always greater than g of x, which is always greater than f of x. So therefore, we can find out the limit at g of x. So this was the brief overview of limits for AP Calculus. I'd recommend you do a lot of outside studying by watching resources such as Khan Academy, Black Pen, Red Pen, and there's a bunch of other really great math YouTube channels out there. I'll put some of the videos in the description. But have fun with that, and have fun in the rest of the year in AP Calculus.